Hi everyone. In today's video, we are going to discuss how FMI technology can be used in creating good workflows and how it can help Modelica enhance controls workflow. So for this, we'll take an example model from Impact. We'll export the model without the controls in Simulink. We'll develop some controls in Simulink and run them together. So this is one of the goals of today's tutorial. And we'll also use a case where we import the controls from Simulink in Impact and run it along with the plant model in Impact. So we are going to do both these use cases. So for this, we are taking an example from vapor cycle experiments, vapor cycle with cabin. And I have already duplicated that to my workspace. So briefly, what this model does is it uses a vapor compression cycle to cool the cabin air's temperature. So how it does is it uses a PID control to takes input from the cabin air temperature, and using a set point, it changes the compressor's displacement till it reaches the cabin air's temperature. Uh, I have already run this model in Impact, so I'll quickly show you the results. So the air bypass valve is constant 0.01. The air temperature in cabin starts from 40 degrees and settles down at 5 degrees, which is our set point temperature. And to do that, the compressor displacement also changes from 1 to around 0.56. So these are the results that we get from Impact. So the first step in creating the model, the plant model, and exporting to Simulink is creating interfaces to this model. I have already done that. So interfaces can be created using Modelica, blocks, interfaces, real input and real output. So these will act as interfaces to the model. So I'll show you quickly how the plant model looks like. So in the plant model, what we have done is instead of connecting the cabin air's temperature directly to the PID, we have removed the PID. We are using cabin air temperature as the output. And we are also selecting compressor's relative displacement as an input. And the controls is something that we are going to set up in Simulink or in a different tool. Just for reference, here we have also added a first order filter between the compressor's relative displacement and the vapor cycle, so that the signal that we receive from another tool, that is smoothened out using the first order filter. And we have also created a controls model. So in controls model, we have done the opposite. We have just used a PID controller, use a set point. The PID uses temperature sensor output as the inlet or the input, and the output from this PID is the compressor's relative displacement, which will feed into the vapor cycle. So using these real input and real output interfaces, we have created two different models. One is plant model, one is controls model. Before exporting the FMU to Simulink, we'll first test in Impact itself if this model works fine or not. So for that, I have created a test bench for vapor cycle with cabin. And we have just dragged and dropped these plants and controls model and then connected them together. To connect them, what we have done is we have just selected these interfaces, and we can check the names here. So this is compressor relative displacement, and this is also compressor relative displacement. So we'll just select them together and connect them. And similarly, here we can see this is output temperature sensor, and this is also output temperature sensor. So we can connect them together. So that is how we have set up this model. I have already run this for you. So let's go directly to the result. And you can see the result matches from the default vapor cycle with cabin model that we have in Impact. So the results are a complete match. Here the temperature reaches 5 degrees. The compressor relative displacement goes from 1 to 0.56, and the bypass walls opening is set as 0.01. So we are relatively sure that the model works fine. To export the model, what we will do, we'll right click on the plant model and click on export FMU. Once we do that, Impact gives us two options. One is model exchange, another is course simulation. So in model exchange, the solver is not embedded with the FMU. In course simulation, the solver is embedded with the FMU. So we'll go with the course simulation, and we can choose the C word as a solver, and relative tolerance is set at 1e minus 7 for this case. So we'll choose that. Here we will also click on export settings. So here it tells us different target platform. We can choose Windows or Linux. And if we want, we can select other compiler options. But for now, we'll just choose Windows, course simulation, C word, and 1e minus 7 relative tolerance, and click on export. So once we click on export, Impact compiles the model and downloads it as an FMU, which we will use it to import in Simulink. So I have already done that. So let's start with the Simulink side. So in Simulink, we'll add a block. To do that, we'll double click here and search for FMU. So you will see here, it gives us three different options. So first is the Simulink native block FMU. The second and third option is FMU ME and FMU CS, which are the options that you get once you have installed FMI Toolbox. For this exercise, we are going to use FMI Toolbox to import the FMU. Since it is a course simulation FMU, we'll select FMU CS. Once we do that, it creates a block FMU CS. I have double clicked on the block to open its options. And here we can click on load FMU. And this is the downloaded model, the downloaded FMU. It will write the full path with FMU, and we'll click on open. So once we do that, it will load the FMU into Simulink using FMI Toolbox. Once it has done, we can see it has different settings here. It has different variable options. You can see it has a temperature output, temperature sensor, flow source, heat source, bypass wall, vapor cycle, and so on. So if we want, we can select on these different variable, click on compressor. If we want, we can change the values from here. But for this example, we are using the default values, so we will not change any values. Also, you can see it has an input port and an output port. So this is created from the Modelica blocks interfaces real input and real output. And because of this, we can set up controls in Simulink and connect them to this respective input and output blocks. I have already done that for you. So we'll close this and open the model that we have. So I've already imported the plant model and set up PID controller, which uses a temperature outlet from the temperature sensor and uses a set point from this ramp. And using this sum block, it feeds the error to PID controller and it sends the compressor relative displacement values to the FMU. So this is our Simulink model setup. Next is we'll click on modeling and click on model settings. So in model settings, we can click on the solver, set up our start time and stop time. For this, we will use 1000 seconds. And solver selection is immaterial. We will just keep it as the default value, because for course simulation FMU, the solver is inbuilt in the FMU. So this solver selection will not matter much because this is the master solver for the Simulink model. So next, the important step is double clicking on the FMU. And once the dialog box opens up, we'll go to advanced here and set up the sampling interval. So this is the interval at which the FMU communicates with the blocks in Simulink. So we are setting it to 1 second, such that at every 1 second, the PID controller is communicating with the FMU and it is generating uh, the simulation. So basically, what happens is the solver restarts at every 1 second, and then it takes that boundary condition as constant. It uses cboard as the internal solver of the FMU. It solves it again for 1 second and then again syncs with the outside blocks of the Simulink. So this is how the model is going to run. And we'll click on run. I have already ran this model earlier because it takes quite some time to run, because we expect it to run at most around the real time, which is around 1000 seconds. So you can expect around 15 minutes or so run time. I have already logged some of the signals. So we'll click on data inspector to see how the temperature sensor output value looks like. And then we're going to compare that with impact. So we can see it starts with around 40 degrees and goes to 5 degrees and then becomes constant. So this is the same result that we get in impact as well. So now we are sure that the model is running fine. So this was one of the steps. Exporting the plant FMU from impact and importing it in Simulink, setting up PID controls, connecting them together, setting up different simulation options like sampling interval, selecting the start and stop time, and then visualizing the results. So we have completed the first step of this tutorial. Now we are going to come to the second step of today's tutorial, which is importing controller from Simulink in Impact and running it together with the plant model in Impact. I have already set up the controller to save some time. I have created a PID controller, used an input and output, given them appropriate names. And we will click on modeling and click on model settings first. So we will open up this configuration parameters box. In the system target file, we will click on browse. And we have selected FMU CS2.tlc. So with the native MATLAB target files, this option will not appear, like the FMU CS1, FMU CS2, FMU CS3, FMU ME1, FMU ME2. So these are the target files which appears when you have installed FMI Toolbox. To export the model from Simulink, we are going to use FMI Toolbox. And for that, we will select FMU core simulation because Impact only allows import of core simulation FMUs. We will keep everything else the same. A solver, we will select a fixed step size 1 second. Solver selection, we will choose fixed step and auto solver. Click on OK. Now we'll go to the apps and click on Simulink Coder. And we will click on this build button. So this will create us the FMU. Since Impact Cloud is based on a Linux, we'll generate the FMU through a Linux platform. And I have already used Linux machine to generate my FMU. So we're not going to use the FMU that we generate on the Windows platform. So this is only to show how the FMU can be generated. So now the build is complete. So once the build is complete, we will get a .fmu file and we can click on this import button in Impact and click on the controller.fmu, which I have already saved and also imported in Impact. Next, we'll go to the test bench. We have created a test bench. In this, what we have done is earlier how we have dragged the plants and the controls model which were created in Impact. In this test bench, we will not drag the controls model. We'll drag the controller which has been created from FMIT and then connect them together. So this is relative displacement and this is also relative displacement. So we'll connect them together. To do that, we'll horizontally and we can connect them together as you can see in the screen here. So this is how we can bring our controller from Simulink using FMIT and connect them with the plant model in Impact. Once that is done, we will double click on the controller. We'll set up the FMI tolerance and the FMI step size, which is 0.1 second and 10 minus 3 here. And we can run this model. I have already done that. Since it takes some time, we'll directly go to the results and check the results from the summary tab. So we can see again, the bypass valve opening is set at 0.01. The temperature sensor drops from 40 to 5. And the vapor cycle compressor relative displacement starts at 1 and goes till 0.56. So these results are consistent with the results that we obtained in the default experiment and also in the test here. So in this video, what we have learned is how we can set up interfaces for the models in Impact, how to export plant model as an FMU, how to set up controls, and how to import the plant model into Simulink and connect with the controls and run it. So this was the first step of what we learned in today's video. And in second step, we exported the controller from Simulink, again using the interfaces, and imported it in Impact. So the export was done using FMI Toolbox, and the platform that was chosen was Linux platform, as Impact runs only in Linux. And we imported the controller in Impact, connected them with the plant model, and ran the simulation and got the results. So this is to show how the FMI technology can be used to generate different kind of controls workflow, and the user can choose the best workflow, whatever they require, harness the power of Modelica for physics-based simulation, and also utilize the power of some of the other tools which are good with controls, and make the best use of all the tools that we have available and run them together. I hope you got something out of this video. If you have any questions, please reach out. Thank you.